Hi, this is Olajide from CTF Security and welcome to another Capture the Flag security challenge. In today's video, we're going to showcase how attackers can gain a foothold through a technique called command injection, which allow attackers to run arbitrary commands on host operating system through vulnerable applications. Next, we will explore a more advanced tactics involving active cron job. You will see how attackers can use active scheduled tasks to access privileged accounts. And finally, we will be demonstrating how attackers can elevate privilege to highest level by performing privilege escalation to root through reverse engineering vulnerable kernel modules. So without further ado, let's get started. Welcome back to the channel. As you can see, our capture the flag name is Athena and we have a tagline saying break all security and compromise the machine. We have our level of difficulty right here, and if you scroll down we have the objective of this task, which is asking us, are we capable of mastering the entire system and exploiting all vulnerabilities? We have some further instructions saying, please allow the machine 2 to 3 minutes to fully boot. This is to allow the system to load all the required services that is being required in this challenge. Now, the objective in this room are in two phases. The first one is we're looking for the user flag by gaining an initial access, and lastly, we're expected to privilege escalate into a higher authority within the system to gain our root flag. So without wasting much time, I'll just hit the start button to load our machine. Now this is going to take an estimate of 1 minute for us to get our target IP address. Now that we have our IP address, we can grab our target IP address. But before we proceed, what I want to do is to be able to reference my IP address using a domain name. So to fix that, we quickly use the sudo pluma /etc/host to edit the host file. Now I'm going to paste the IP address and I'm going to give it a host name, which is athena.thm. I'm going to save. Now instead of accessing the room with the IP address, I can just go ahead and type athena.thm to load the room. I'm going to save, close, and we can head back to our browser. I'm going to be using the Chrome for this. I'm going to paste the IP address, but instead athena.thm, and this is going to load the web page for the Athena room. Now the first thing I want to do is to right click and see if I can check if there's anything suspicious about the source code. So you can see this is just plainly an HTML document. So we don't have any information that could give us access to this particular machine right here. So I'm going to close it. And the next thing we're going to do is to go to our terminal. Now what we can do is just run a quick scan on the IP address. So I can say nmap-sc-sv. The sc is for script scan, the sv is for version scan, and we can issue the name of the room. So I can use athena.thm. So we're just going to wait for the scan to complete. Alright, so our scan has completed and we have some information right here. We have port 22 open running SSH service, and this is the version of the SSH. We also have the port 80 open. We have the 139, we have port 445, which belong to the Samba, which is the SMB shares. We also have some information right here containing the SMB2 security and the versions. So what I'm going to do is let's see, I think I have a previous folder on the YouTube directory. So I'm going to remove Athena. I have Athena before All right, great. So let me remove Athena.txt also. So I'm going to create a new one, make directory, call Athena, and from there we can create a file called Athena.txt. All right, fine. So we're just going to paste some vital information we're going to be getting in this room right here. So let's head back to our room. I'm going to grab the results for the nmap, including the command that we ran. Copy, and I'll just dump it right here. All right, that's interesting. Okay, let's go back. Now, whenever I'm working on a CTF and I was able to find 139 and 445, the first thing I do is to always check it out, because most of the time some relevant information to proceed within the room is located inside the SMB shares. So the first thing we're going to do right now is to try to connect to this share and see if we have any information that can aid our attack or that can aid in getting access to this machine. But before I do that, I would like to open this document this time around so that I can also use this tab by using the upper sign. So we can just reopen that again. Okay, cool. That was an error. I believe I didn't save it before. So let's quickly save that again. Let's just stop here. Copy, paste, and save. I'll just leave some space. All right, great. So to connect to the Samba share, I can clear this. We can use the SMB client application. We can specify the -L to list, and we can specify the IP address, which I'm just going to grab very quickly, and can just drop it in here. So this is going to list all the available shares. No password, just hit the enter key. Okay, nice. So we have a share name called public. So we're going to try to access the public share by removing the -L, then adding /public right here. No password. All right, so we have an SMB shares. From here we can run a command ls to list what we have in this room, and we happen to have a file called message for administrator. All right, so get message for administrator, and we hit the enter key to download the document. We can now exit the Samba share. So I can move the message for administrator into /home, which is the path for my Athena folder, R007/Athena/ okay, I think that's all. So cd Athena, no, that's wrong. cd YouTube, cd Athena. So ls, oh, there's an issue right there. So we'll move it to the wrong folder. So I have to go back here, copy cd, paste it in here. So we're going to move message for administrator into home/R007/YouTube/Athena. So cd YouTube, cd Athena. Okay, great. So we have our file in here. Okay, So let's take a look at the file that we have here. Okay, the content of the message for administrator, cards message for administrator, and we have, dear administrator, I would like to inform you that a new ping system is being developed, and I left this corresponding application in a specific path which can be accessed through the following address, the /my router page. Now we're going to copy this and we'll head back to our program and we'll just add /my router panel, and this is going to load the application that is under development. And you can see the name is ping2. This is a simple ping system for pinging other devices, e.g. the IP address. So we're expected to put in an IP address here, then send a ping command, and this is going to set some packet to the device we're trying to ping, and in response we get back the echo reply. Now we can illustrate this by using the loopback address, which is a local IP address 127.0.0.1. We'll send a packet and we're expected to get a response back. Now this will send 4 packets to the application and we're going to receive 4 packets, you can see it, and 0 packet is lost. Our objective for this room is to see how we can abuse this particular application to either gain a reverse shell. But before we do that, we're going to start small. First of all, let's try a very basic code injection payload. So we can try to use the semicolon, then we try to execute a command on the server, which is the ls, to list the file system for that server. So if I send the request, you can see that we get attempt hacking, meaning there's a security mechanism that is in place inside this ping.php that we have here. So I can go back and use some other special character. So let's say I want to use the pipe symbol and send also. You can also see it, attempt hacking. Okay, what if I just use a basic ls and send? You can see fail to execute. Now that means they are probably filtering some of these special characters that I'm trying to use to bypass this particular ping application. So what we're going to do next is to try to intercept this and load some of the basic command injection payload into this application to see if it will be able to bypass the security measures that we have. So let's go to the internet and download some basic command injection payload. So I'm going to go to the internet and click on the new tab, and we're going to search for command injection payload. Okay, so we're going to go with the first one from github.com. Great. So if I scroll down, we're going to see some basic command injection here for Unix. So scroll down. Okay, we're going to stop right here. I'm going to copy and let's head to since we're working basically for Windows, so we're going to for Linux, we're just going to stop right there, but you can also use a Windows payload. So let's move to, sorry about that, let's move to our application right here. Now what we can do is to load another page. So I can use Ctrl N and we can paste this payload in here, and I'm going to save. So we're going to give it a name, so let's call it cmd payload, and we're going to save it inside the Athena folder, and we're going to paste it here. We can make a confirmation for that. ls cd, I need to move this. Okay, cd Athena ls. So we have our command payload. We can cut cmd payload. You can see all the payload in here. Now to use this payload, we're going to head to our Bob suite and make sure the intercept is on. And we head to our application, we just send a dummy request. And this is going to get captured by the Bob suite. And once it is captured by the Bob suite, you can see the post request that we're sending, which is a method. You can see some list of headers that are being sent along as a request message to the server. We also have the data that are being sent. Here we have two parameters, the IP parameter and we have the submit parameter. So we're focusing on the IP parameter here. I'm going to right click here and send to repeater. At the same time, right click again, and this time I'm going to send to intruders. Now we're coming back to repeater, but first of all, on the intruder part, we can kind of try to manipulate the parameters that we have here, but we're not manipulating the 127.0.0.1. So we're going to clear it and set our own payload. So I'm going to add payload here. You can just give it any name of your choice, just for you to be able to identify the parameter. I'm going to select it. We go to sniper. Okay, we're still using the sniper. So we'll go to payload and we're going to load this payload in here. We have Athena, we have CMD payload, and I'm going to open. So you can see the list of all the payload that we got from GitHub. I believe that is all, so I'm going to start attack. No payload was defined. That is strange. So let's go back and see what the problem is. What was the problem? Oh, sorry about that. I'm missing out something. Is that the same payload? Okay, so we expected to select the parameter and add. We can now confirm our payload data, which is accurate, that we can send. So we have an estimate of about 102 brute force attempts that this Bob suite is going to perform. Now, as Bob suite is sending this payload into this particular application, you can see it responding back with some information like the status code. We have the length also, so we can be able to tell if something has changed based on the length that is being returned from the server. Now, if we use the 190 for example, and we go to the response, you can see the message that we got failed to execute the ping. Now, if we go to the 183, you can see the kind of response we are getting: attempt hacking. So meaning that all these requests that is coming back with 183 length are just telling us that there's an attempt to hack the program we're working on. We're just going to give this some time to load so that we can have other length within the brute force attack. I'll scroll down. You can see it's still 190, failed to execute ping, 190, 183, 183 also. Let's scroll down. Alright, so we have a different length, 3601, and you can see this returning with the value of etc/password. You can see them, the root, the daemon, and other relevant users within the system. So we can see that we have a particular user called Athena, we have another user called Ubuntu right here. That is interesting, meaning that we have found a payload that works. So if we scroll down, let's take a look at the request that was sent, but meanwhile I can stop the attack. Okay, now if you scroll down and take a look at the payload that was used in this request, you find out that we have the percent, the 0a cat etc/password. Now if you take a look at this part here, from the percent up until the letter A, that is the special character that was used to bypass the filter. Now we can make some investigation on this by copying this and going to the internet. We'll just go to a new tab and let's go with URL encoding W3 school, and let's see what this transcribe into. Okay, we'll go with the first link. Okay, so we'll scroll down and we can try to find this on the page. Since we have a lot of data here, I'll just paste the value in here, and you can see it %0a, which actually means LF, line feed. And again, you can make more investigation on what line feed means. You can see it is the action making paper or printer to move one line. Another name we can use to qualify this line feed is the new line, which is the /n. Now, since we know that the /n is the special character that bypasses this filter that we have in this application, what we can do is to head back to the Bob suite, to the brute force. I can right click on this request and send to the repeater. And when we go back to the repeater, let's head back to the repeater. Okay, cool. We have the request here. So I can just send it again to confirm that we have the right request. Cool. So you can see the output of the etc/password file right here. I can manipulate this data here. Let's remove from this cat here. I can decide to check if we have which URL encode plus nc ncat, and I can send. And this is supposed to return the path to the ncat binary. You can see it's inside the usr/bin/ncat, meaning that we can use ncat for our reverse shell. So without wasting much time, I'll just go to the browser and I can just use this one. Let's go for reverse shell pen test monkey. So that we can grab the reverse shell command line from there. I'll go with the first link. So we're going to grab the link here. Okay, this one is for bash. So I'm looking for netcat. We're going to copy this. And we're going to head to our Bob suite. And we're going to replace the command here. Make sure you don't touch the the %0a, which stands for line feed. So we're going to paste the command here, and we're going to URL encode by highlighting Ctrl+U. Now, before we send this command, we need to make sure that we have the ncat listening on a certain port. So first of all, I need to put in my IP address in here, and I can do this using just another terminal. So let's use this one. I can go with the IPA and fetch my local IP address here, copy, and we can take it into the Bob suite and replace our local IP address, and we're going to maintain the port 1234. So I'm going to go to my terminal here, ncat-lvp1234 listening, and we're going to send this request again. Okay, great. So I'm going to paste. So we'll just work with export temp equals to xtemp. Okay. So next we can just going to run the stty raw let me just omit this, so I can just do away with that since we're not going to be spending much time on this data. Now what I can do is look for a file that can enable us to carry out our task. But before I proceed, we have ping.php, which is an interesting file. If I cut ping.php, you see that this is the PHP script that is pinging any IP address that we supplied, and when it falls within the special character that they are validating, it just showed you the attempt hacking. Now if you scroll down, this is what is executing the command, and if you scroll down, this is what they are filtering out. So once you have the semicolon in your program, in your bypass payload, or you have the ampersand, or you have the piping symbol, this rejects whatever command that you're trying to put into the application. So I'm going to clear this. Now what we can do is to cat /etc/password. We have all these user, especially the one of 1001, and we have another one 1000, which is the first user, and we have this one as the second user. Now since Athena is a particular user on the system, I'm more interested in the Athena to see what kind of command Athena can run, and if we can be able to gain access to Athena's account. Now to do this, is either we do it in two ways. We can either use the find command, or we can use the wget to bring in an external script. Now you can use the who am I to know who you are on the system. So we are www data without a privilege within the application. So let's run the find the root from the root directory. We want to be able to find a particular user. The username is Athena. Let's close that. We're looking for the, let's pipe let's pipe error messages in case if you're not able to find data. As instead of throwing error on the screen, we can redirect the error into the /dev/null directory, and we're going to execute, and this is going to run through the application root directory to find files that are relating to this specific user, Athena. Now if you go back, let's check the time for our shell. You can see we have an estimate of 15 minutes left for the machine to expire, so I'm just going to add one more hour to this to enable us finish the room. So we'll head back to the program, and our search is done, and we have two directory. We have the first one, which is the home/Athena, which we can access, and we also have the user/share/backup, which we can access. Now this backup looks interesting, so I'm going to grab the directory and let's see what we have there. So cd, we'll paste it in here. Now if I check what we have on the directory, we have a file called backup.sh. now if you use the ls-pls to check for permission, you can see that we as a user own this file. The group that own the file is Athena, but the owner of the file is www data, which is our file because we are logged in as www data. Now we can see the content of the file by using cat backup.sh. You can see the file content. Now if you take a look at this script, we can see that this is a backup script called backup.sh, and it is performing some operation here, like setting a variable from this backup dir zip to /backup, making a directory and copying it into backup.dir zip. We also have copying the content of this directory into this particular file name, and lastly we have creating a zip file with this specific name and removing the file after the zip file is being created, and lastly to just echo backup completed. Now I want to be able to see, since we have access to this file, how we can abuse this file to gain a reverse shell into the Athena directory anytime this particular script is being executed, because it looks like it's an automated script. So we're going to create a listener. Let's use ncat -lvp with another port, this time around 12345, no, 1235 instead. And we're listening on 1235. We need to be able to add to this particular script or modify to it. So we'll head back to our cheat sheet. This time around, what we need is the bash script. So I'm going to grab the script here, copy, and we head to our shell. So we can add to this by using the echo. I'm going to paste the bash file. But before I paste, I need to make sure I edit it because I don't have a standard pty shell. So what we can do to fix that is to load, let me just do something here. Let's cd into YouTube, cd into Athena. Do we have the file here? Okay, we don't have it here. Go one step backward. Okay, it's right here. So I can use the plumber to open the athena.txt. All right. So I can first of all paste the payload here and make my modification to the payload. So we need, let's go back here. I can exit this first and use the IPA to grab that IP address one more time. So I will just copy and let's drop it here in case we're needing it next time. So we'll just call it local IP is equals to this. Great. We're going to modify it. And we're going to specify the port 1235. So we're going to copy this payload, copy, and we head to our shell, paste it in here, close the code, and we're going to redirect this by appending it to the file called backup.sh. Okay, so let's cat backup.sh to see if it works. So you can see that we've added one line of code to the existing file that we have. So this is expected to give us a bash reverse shell binding to this particular IP address on port 1235. So we can clear this and relaunch our netcat to listen for connection. So we're just going to wait for the program to execute to give us a shell. Thought I added an hour to this machine. What's the problem? So we still have 1 hour 4 minutes left. All right. So now that we've gotten access to the Athena account, what we need to do is to stabilize the shell. And in order to do that, I have the file already here so that things could move a little bit faster. So I'm just going to send the Python import pty command. Next, I'm going to export the term. And I'm going to put this in background, and I'm going to use the sty, then send it to the foreground. Okay, cool. All right. Now we've stabilized our shell. I can clear this. Before I proceed into getting a root access, first of all, I want to view my user's flag, so I can ls to check what we have in here, cd to the /home /Athena, and from here we can grab our users.txt. Just quickly grab this, copy, and we can just scroll down and put it in here, submit. And that was correct. Let's move ahead and escalate our privilege to gain the root flag. So move back to our machine, and first thing I want to do is to check what I can run as sudo privilege. Now you take a look at what we have as the output. We have this particular application can execute against the venom.ko without password as the root, which is very interesting. So I'm going to check that directory out, copy and cd to that directory. Okay, so we just have a single file there, which is the venom.ko. First of all, we need to check what kind of file is this venom file, ko, and you can see it with just the extension. It is ELF 64-bit LSB relocatable for 86 to 64-bit version, and the .ko stands for the kernel file. So what we can do is to kind of move this file out from this machine and move it to our local machine, and we're going to decompile the venom.ko file to see if there's any means whereby we can privilege escalate as the root of this machine. So to do that, I'm going to serve this file on my HTTP server. So Python 3, we're going to use module http.server, and we're going to use 9000 to serve this file. Okay, good. So we are serving on any IP address on port 9000. I'm going to come to my own machine and make sure I don't have any file called venom.ko. All right, cool. So we can use the wget, then we can use the HTTP, which is the domain, athena.thm on port 9000, and we can serve the file venom.ko. So now we are downloading the file from the remote machine. So let's take a look at what we have. We have venom.ko. So what I'm going to do now is to upload this file to Ghidra and try to decompile it so that we can have a look at the source code of the application. We're going to be using online for this, and we have this application called the Compiler Explorer, and it's an online application. It's more of like a platform that combines different reverse engineering application together in one central location, and you can see the different supported applications like the Anga, the Binary Ninja, Boomerang, Ghidra, which is one of the most popular reverse engineering application. So what we are going to do is to reload this page. Okay, cool. So I can actually upload my application here, which is the venom.ko, but you can also read the instruction here. It says your file must be less than 2 megabytes in size. That is the support for this application. If you're analyzing any file that is above 2 MB, I would recommend you use the inbuilt Ghidra on your Linux operating system. So what we're going to do is to quickly select browse, and we're going to select the venom.ko. We'll click on open, and this is going to decompile the venom.ko application. Now you can see that other option is selected. We'll just deselect them. Select, deselect. Okay, cool. So we have just Ghidra selected. So you can scroll over the code to take a look at the full source code, or I can just copy Ctrl+C, and I'll head to my text editor, which is Pluma in this case, Ctrl+N to open a new page, and I'll paste it in here. So I can save it and give it a name. Let's call it Venom. Click on save. And from here, we can actually analyze the source code. First of all, we see that this is a C programming language and it has some inbuilt functions within the code. I beg your pardon, it has some function declared within the code. Some of these functions are the long hacked get dent. We also have the long hack get dent 64 and couple up with other functions. But one of the functions that interests me more, because my idea of reverse engineering this application is to actually gain root privilege. So fortunately for us, we have a function called give root, and this give root function is meant to give privilege access or root access to a user that executed that command, provided some conditions are being met. And this give root kind of changes the modules to hidden by setting it to 0. You can see it. Each of the modules are being set to 0, and this is why if you go to the program, so let's just exit the HTTP server. I'll just use Ctrl C. Okay, we can clear this. First of all, we can execute the sudo -l and grab the command that we can run with sudo privilege, which is the ins mode. So we can use this to load the kernel. Sudo paste. Okay, as you can see, we got no permission error because we can actually execute the code without a password. Now, if I run the ls mode to check the kernel devices, and I grab if we have any venom file in the kernel, you see that we return with nothing. So this is because the program is actually setting the value to 0, which is the hidden value right here. So what we can do is to check the next module. Now if I scroll down, you see that we have another function called hacked kill. Now this hacked kill function is interesting because it actually performs some conditional operation. For example, we have a declaration of IVA3 to be the PT register, which is directed into the SI, which is the signal ID. Now, if our IVA3 value or the signal ID that we pass to the IVA3 is equals to 0x39, which is an X number, it run the give root function, which is the previous function that we take a look at earlier. Now, the other condition says if IVA3 is 0x3f, which is also an X number, this kind of hide the module. In the situation whereby the module is already hidden, when you supply the 0x3f, it unhide the venom.ko module, meaning that we can capitalize on this hard kill function by supplying the 0x39 and the 0x3f to the application. But first of all, we need to know what this means in decimal. Now to do that, we're going to move to the browser here. We can go on a new tab and we can say hex to decimal. Okay, good. So I'm going to go with this option, hexadecimal to decimal converter. And we can go back to our source code and just grab the value in here, copy, and we'll head here. We're going to paste it in here and convert. So you can see this transcribed to 57 in decimal. So we'll go with, so let's go and document that. We're going to have the 0x39 is equals to 57. So we need to find the other value, which is, let's go back here, 0x3f. Copy and head to our converter. We're going to paste and convert. So this transcribed to 63. I'm going to copy, we'll head back and we document 0x3f is equals to 63. Now let's go back to the script. Now first of all, I want to make sure that I load this kernel file again, sudo, just to be sure. That's strange. Okay, let's see. Maybe it's because I've loaded it before, so I can kind of exit. So we can use the, let's use the kill, and let's use the 63 to load or to activate the venom.ko, and let's use 0. Now if you take a look at the command we're using here, we're using the kill as a command to send signal, and the signal ID we are sending is 63, and the 0 specify the process group ID, which represents all process in current session. And now if we check using ls-mod and we grab, just like we did earlier, venom, you see that we have the venom kernel loading or loaded already. If you take a look at the output we are having, you will see that the venom kernel module has been loaded with a size of 16,384, and the column here showing 0 is used to show the number of other kernel modules or components that are currently using or depending on this venom module, which happens to be 0. Now what we can do to gain privilege, first of all, let's check who we are. Currently we are logged in as Athena, and to gain access we just change the signal ID to 57. So we're going to use the kill dash 57 0, and we execute. Now if we check who we are, and you can see that we are root. Now if I say who am I, you can see that we have privilege escalated to this machine by reverse engineering the venom.ko. Now let's grab our root.txt. So you can see this /root and ls, see what we got. So we got two files, the f-society and the root.txt. So we can easily cut root.txt, and we can grab our flag, copy, and paste. Okay guys, that will be all for this video. If you've learned one or two things, make sure you like, subscribe, and share. See you in the next video.